Limits and L'Hopital's rule. Okay. I think L'Hopital's rule actually has an A and a little accent caret thing there. I'll have to investigate. Okay. So the idea here is limit as x approaches infinity of x tangent of pi over x. So, despite our hint here, which we would not get in reality, probably use limits and L'Hopital's rule. So the idea with L'Hopital's rule is if we plug in infinity for these, so let's write this out real quick. So whenever you see tangent of x, your first thought should be to convert it to sine and cosine. So this is x sine of x over cosine of x. And if we take this to infinity, pi over x. There we go. If we take this to infinity, then this would be sort of like infinity. I know you're not supposed to do this. You're not supposed to write out infinity. I should be writing out x as it approaches infinity. Sine of 0, because pi over infinity is 0. Cosine of 0. So this would be 0. That would be 1. And then indeterminate form we got is pi times 0. Indeterminate form is we just don't know. We have an immovable object meets an immovable force or some such. And the idea is we don't know. So what we do then is we do L'Hopital's rule, which the idea is we take the derivative of the top divided by and the derivative of the bottom, and that will give us the same limit. The challenge here, though, is we don't have an obvious bottom. So I'm going to rewrite this x as 1 over x, 1 over 1 over x. There we go. Because when you divide by a fraction, you multiply by the reciprocal. So this is the same as 1 times x over 1. So what we're going to do here, move this guy over there. We'll do tangent of pi over x times 1 over x. Same thing. So, and I just left off the limit portion because convenience. So now we take the derivative of both sides equals limit of x approaches infinity. Derivative of tangent squared is secant squared of x, which is 1 over cosine. But then we have to multiply by the derivative of the interior, which is the chain rule. So there'll be a pi involved. And x to the negative 1 derivative equals x to the negative 1 times negative 2, which equals negative 1 over x squared. There we go, negative 1 over x squared. And intuitively when I see that, I'm like, oh, derivative of 1 over x. Well, that's probably the natural log of x. No, it's a trap. Be careful about that. The integral of 1 over x is natural log of x. And then the derivative of the bottom is also, which will be negative 1 over x squared as well. And so the idea here then, so with L'Hopital's rule, we can just take the derivative of the top, derivative of the bottom. This isn't taking a derivative of a quotient of a fraction, because then we'd have to do the, people say the quotient rule, but I always just rewrite it in terms of using product rule. So this is not a product rule situation. Whoop, didn't mean to cross that guy out quite yet, but now I am going to. I feel bad. I probably crossed it out and got all depressed, and I gave it a reprieve by uncrossing it out, and then I just crossed it out again. I feel like a terrible tyrant. Okay, so then we do limit as x approaches infinity of, instead of saying secant, I'm going to say 1 over cosine, because secant is 1 over cosine, and it's easier to visualize in that way. Times pi, change color to add emphasis. Cosine of pi over infinity is cosine of 0, which goes to 1, which equals pi. So 1 over 1 is just 1, and what we're left with is pi. So the limit will be pi, which is one of our possible answers. Huzzah! So, get a better circle. There we go, pi. So that's how you do L'Hopital's rule and limits.